Hi. Okay, this is video 2. Now this might be a long one, so definitely you're going to want to take really good notes because remember you're going to turn those in for your attendant. All right, so let's go on with some extra terms. We did talk about chords in the previous video. What if a chord crosses through the center of a circle? Now remember, a chord is a line that is a segment of a line. It's a segment with its two endpoints on the circle. That is what a chord is. So keeping that in mind, if we have a circle and we have a chord, say we have this red chord, it does not go through the center, right? But it's still a chord. What if a chord goes right through the center of a circle? We're going to pretend like that is the exact center. Hopefully that looks familiar to you because you've seen it for a long time in your math. That chord that goes right through the center is also known as the diameter of a circle. The diameter is nothing more than a chord which passes right through the center. Keep that in mind. Sometimes they will present questions to you and they will say the chord passing through the center of the circle has a length of 12. Well, by telling you that, they just told you the radius equals 6. So you're going to have to infer information like that from details like the chord of the diameter. Okay? So just be ready for that. All right. Moving on. In addition to a chord, put this up there by that. We have a couple of other terms that we want to learn. A secant and tangent. So the secant of a circle is a line, not a segment, a line, which intersects a circle in 2 points. It crosses that little yellow line, the circle itself, it intersects it at 2 points. The tangent intersects at only 1 point. So sometimes it might be easier to see this demonstration with a visual. So the secant we'll make in blue. A line which intersects a chord in intersects a circle in 2 points. There might be our secant. I'm going to get this chord off of here, the diameter. Okay. Now remember that first chord we had. What is the difference in a chord and a secant? A chord is a segment or a piece of a line with endpoints on the circle. The secant is a line. It never ends. They both have 2 points on the circle, there and there. Whoops-a-daisy. But you see the secant never ends. So this is our secant. Okay? Now let's look at a tangent. A tangent will intersect at only one point. It might intersect at this point right here. Supposed to be green. And that is what a tangent is going to look like. The line could be a segment, could be a ray. The point is it only intersects at one point, touches the circle one time, right there. That is your green one. That is a tangent. So I would draw this diagram. Go ahead and pause this video and get this diagram in your notes because you're going to need it. You're going to need these pictures in the next activities that we're going to do. Pause the video, draw that picture, get these definitions down. All right. You didn't pause the video like I said, now it's time to rewind it. So, with circles, you have several formulas or theorems when we start to discuss arcs and the measure of angles. Now, our first bit of activities, we're going to be focused on finding the measures of angles and not the lengths of line segments. After we do this about angles, then we're going to switch. We're going to go back through and use these same theorems and things for finding lengths of line segments, excuse me. All right, so theorem 1. This is when you have two chords and then new term, inscribed angle. Now we talked about the central angle. The central angle is when the vertex of that angle is on the center of a circle. This is not a central angle. So keep that in mind. We're not talking about a central angle. We're talking about an inscribed angle. Remember the difference, and let me just go ahead and draw some. So the center of the circle is right here. Now, a central angle might look like this. The vertex is on the center of the circle. Be aware that is not what we're referring to in this activity. Not this one. But you need to remember what that is because we will be still talking about central angles. But for now, we're talking about an inscribed angle. So what do we need to know about an inscribed angle? It's made up of two chords. Okay, remember in your brain, think back, what's a chord? A chord goes across the circle. A chord is a segment. It has two endpoints both on the circle. So we're going to take two chords and we're going to make an angle out of them. Maybe it would look like this, and there's an infinite possibility of what this chord could look like, or what this inscribed angle could look like. I am going to draw this one. There is my inscribed angle. The inscribed angle is right here. I can't type today. Right here in the there. That is the inscribed angle. Okay? let's put some points on here because we're going to do some stuff with this. So we're going to have point A, point B, and point C. I need you to be drawing this diagram with me. So here's point A, point B, and point C. If you have not drawn this picture, pause the video and get it drawn. All right. There is a theorem that goes with this situation, and it's the inscribed angle equals 1/2 the measure of the arc that it encloses. So for this one, for this situation here, we're going to have angle B equals 1/2 the measure of AC. Angle B equals 1/2 the measure of arc C. Angle B equals 1/2 the measure of arc C. Now what if you're given angle B? So this might be example number 1. We're given angle B. And angle B equals 70 degrees. So you're going to plug that right into the formula. Angle B equals 1/2 the measure of arc AC. And in this situation, they would be asking you to find the measure of AC. So they've given you the angle, and they want you to find the arc. Plug it into the formula. Do you remember how to get rid of a fraction? Multiply by the denominator. You've got to remember that. So we're going to multiply both sides of this equation by 2, and that's going to cancel this fraction out for us. So 2 times 170, 2 times 70 is 140, and that is going to equal the measure of arc AC. So for this, we were given this was 70, and we figured out using the theorem that this was 140. Conversely, you're going to be given the arc measure and have to find the angle measure. So in example 2, the measure of AC equals 60. And we want to find angle B. So the measure of the arc, AC, is 60. Find angle B. So here's an example 2. Out here is 60 degrees. Find angle B. So angle B equals 1/2 the measure of arc C, which is 60. Angle B equals 30 degrees. So in example 2, angle B is 30 degrees. That's exactly how you're going to use, what formula you're going to use, what theorem you're going to use when you have a picture with 2 chords and an inscribed angle. You need that formula right there. I would draw this picture with this formula, with this definition, so that you know on the worksheet and in your study island, you can have your notes out and you'll know exactly which formula or theorem to use, because we're going to have several of these. All right? Next theorem. When you have a tangent and a chord, a tangent and a chord. So remember, the tangent is a line that touches the circle at only one point. So if we have a tangent chord scenario that forms an angle, for instance, let's get some examples on here. We could have that right there. Point A is our tangent point. Here is our tangent line, and here is our chord. Now let's assume that we're given, put some notes so I can have a good example, that, excuse me, chord AB and tangent AC. So we'd have a point here. That was C. That's the kind of picture you might see on your worksheets. So the problem says you have chord AB and tangent AC form an angle of 25 degrees. Okay? So that tells you that angle BAC equals 25 degrees. You can just notate that right here. 25 degrees right there. Okay? There's a formula that goes along with this that says the measure of the arc when you have a tangent chord situation or example equals 2 times the angle they create. So in this situation, the measure of arc AB equals 2 times the measure of angle BAC. Let me draw some little. So if we're supposed to find AB, all we have to do is multiply by 2. So the measure of AB equals 2 times 25. So the measure of AB equals 50 degrees. Okay? Conversely, if you're given the measure of the arc and you have to find the angle, you're going to simply divide by 2. So let's make another example. Let's say we have this one here. Oh, let's work it from the other point of view. So now we have angle ABD is formed by tangent BD and chord AB. So here's our blue example. Angle ABD is formed by chord AB and tangent BD. And if we're going to be correct with our symbols, the chord is a segment and the tangent is a line. So you want to get those there. Okay. And we're going to be given the measure of the arc. What is the arc enclosed by this angle? So this could be a little confusing. We are talking about this arc right here. Okay. We're going to say it is 310 degrees, and that's what we're given. So the measure of arc AB equals 310 degrees. Find the measure of angle ABD. All we have to do is plug it into the equation. So 310 equals 2 times x. That's our angle. We're going to let angle ABD equal x. Remember, we draw a picture, make an algebraic equation. We've been doing this since the first day of class, and I told you we would do it over and over and over. So we're going to put x in place of our variable that we don't know. You're going to divide both sides of this equation by 2. Twos cancel out. 160 equals x. So this is 160 degrees in this angle. So that's using a tangent and a chord and finding the measure of the arc and the angle. Notice we've not done anything with the length of this line segment yet, or this chord. That's in the next group of lessons. For now, we're just concentrating on the measures of angles. Okay. So we have another situation. What if we have 2 chords that intersect inside the circle? One. Two. So for this one, we have chord, chord. 2 chords intersect, forming 4 angles, really. Now, I hope you remember that this angle must equal this angle because they're what kind of angles? Vertical angles are always congruent. You can't ever forget that. If those two angles are equal, what do we know about these two? They're also vertical angles. They're congruent, okay? Vertical angles are always congruent. That's where they share the vertex and they have sides that are common rays. Well, there is a formula for this, and it looks like this. So we got to label some points. So that our diagram makes sense with our formula. So we have point D, point E, point B, point A, and point C. The measure of angle ABC is the average of angle of arc AC and DE. The measure of angle ABC is the average of the measure of arc AC and arc DE. Now this holds true for the other angles. So the measure of angle DE would also be the average of these two arcs. But the other set of angles, the measure of angle ABD would be the average of these two arcs. So either set of arcs. So the measure of the enclosed angle included angle is the average of the measures of the included arcs. So you actually have two pairs here. It's not just this area and this area. You can also be talking about these two, okay? For this example, we're going to specifically talk about angle ABC. So the measure of angle ABC is the average of the measure of arc AC and arc DE. Let's put some measurements with this. Let's say that we're given arc DE equals 60 degrees and arc AC, that's backwards, DE equals 100 degrees and arc AC equals 60 degrees. Find the measure of angle ABC. Let's put in there what we've got. So we said DE is 100 degrees, AC is 60 degrees, and we need to find this right here, ABC. That's our X. Once we find ABC, we've also found DBE because they're vertical angles and they're the same. So we'll just plug it right in. All right, here's our formula. The measure of angle ABC equals 1/2 the sum. So average. Average is you add them up and divide by how many there were. Average of two numbers, add them up and divide by 2. If you were averaging 3 numbers, add them up and divide by 3. Well, we're only averaging 2. We have 2 arcs, arc AC and arc DE, so we're going to end up dividing by 2. The measure of angle ABC, which is what we're trying to find, that's our X, equals DE plus AC, all divided by 2. That's our average. How do we get rid of a fraction? Multiply both sides by the denominator of that fraction. When you do that, that cancels. So 2x equals 160. Divide both sides by 2. X must equal 80. And there you go. You do the same process with the others. Conversely, if you're given, next, on to the next one. So we have 3 situations left. I'm going to stop this video. No, I'm not. I lied. We're going to go ahead and go on with the next one. All right. The eraser out. 3 more to go. When you have a secant and a tangent that form an angle. That's what we're dealing with right now. A secant and a tangent that form an angle. Excuse me. So we're going to have a couple points. Goodness. See if I can fit these in here. So here's our secant. Remember, the secant crosses the circle at 2 points. It could be a line, a ray, or a segment, whatever. It can't be a segment. It could be a line or a ray. This is a ray because it has one endpoint. It could also be a line. We could have had this secant. Either way, that's a sequence, a line or a ray. For this example, we have a ray. Now let's get our tangent in there. Might take me a couple of tries to get this one drawn. Look at that. So our tangent crosses the circle at 1 point. And there we go. Let's see if I can get this arrowhead off there. Good job. And these are both lines. They have arrowheads on the end, but I'm a little off to the corner of my page. All right, so we have a secant and we have a tangent that form an angle outside that circle. Let's label some points. So we've got point A, point D, point B, and point C. Go ahead and get your picture drawn. You need the picture to go with your worksheet, I promise you. AB is a secant, BC is a tangent, and we have a formula. If you notice, these two, the secant and the tangent, form two arcs. They have AC, there's one arc they form. The other one is CD. So you have to be careful. The measure of the angle created equals 1/2 the large or major arc minus the small or the minor arc. There's your formula. This angle, angle B, equals the pink minus the blue. What if we're given the pink arc is 130 and we're given angle B is 30 degrees? So our formula is going to look like this. Angle B, the measure of angle B, equals 1/2 measure of arc AC minus the measure of arc DC. The measure of angle B equals 1/2 of AC minus DC. So the measure of angle B, we know 30 equals 1/2. AC, we know, is 130 minus X. So in this one, we were given arc AC equals 30, angle B equals 30, arc AC equals 130. This is what we were given. And they wanted us to find DC. So we're going to let DC equal X. We were given AC and angle B. We're supposed to find DC. So we're going to let the measure of DC equal X. Then we're going to work out our formula. How do you get rid of a fraction? I hope you know by now. Multiply both sides by 2, and this cancels out. So 2 times 30 is 60. So 60 equals 130 minus X. Subtract that 130 from both sides. That gives you a negative 70 equals negative X. Divide both sides by negative 1. Those cancel. 70 equals X. Those all cancel. So we have just found the measure of arc DC to be 70 degrees. Okay? What if you're given the measure of two arcs? So let's do example 2. We're given AC equals 80, nope, 120, DC equals 80. We're given that. Find the measure of angle B. To set up our equation, we're going to let B, or angle B, equal X. And plug it right into our equation. So X equals 1/2 120 plus 80. X equals 1/2 of 200. Whoopsie daisy. I have a minus in there. This is a minus, the big one minus the little one. X equals 1/2 of 40. Therefore, X equals 20. So that's how we would find the angle. So we're given that this was 120. We were given that this was 80. So we know that angle B must be 20. And that is what you do when you have a secant and a tangent that form an angle. Okay. Whew. What if you have a tangent and a tangent that form an angle? Well, we have a formula for that too, as you might have guessed. The measure of the angle equals 1/2 the major arc minus the minor arc, kind of like the one that we just did. So we're going to say we're given major arc AC, excuse me, not AC, XC equals 220. Minor arc AC equals 140. Find the measure of the included angle B. You have to get from that to a picture. Remember, they always give you some information in geometry. We're going to draw a picture. Then we're going to set up an algebraic equation. So let's draw our picture. I know we've got a circle. And I know we have two tangents. Maybe this one and this one. See, they intersect. Whoops, that top one is not right. There we go. It's better. Two tangents. So we have points on here. A and C, I know. And angle B. They told you something in the given information. They told you that the major arc was AXC and the minor arc was AC. The minor one is this smaller one, AC. Therefore, where does X have to lie on this circle? X has to be in the major arc. You can tell that because they told you in the given information that AXC was the major arc. That's the big one, AXC. And they've given us some information. They've said AXC is 220, and the other one, AC, is 140. Find the measure of the included angle B. So we're going to let angle B equal X. Now we're going to set up an equation. So the measure of the angle B, X, equals 1/2 the major minus the minor. 220 minus 140. So the measure of angle B equals 1/2 times 80, which equals 40. Morning, Connie. Excuse me, y'all. So X equals 40 degrees, which is also angle B. Okay, all right, last one. What if we have a situation where we have an inscribed angle? We haven't really talked about that term yet. We have an inscribed angle and a central angle. And we want to find arc and angle measures. Well, let's draw this out. Let's draw an inscribed angle and a central angle. Remember, the central angle is formed when the vertex of the angle is on the center of the circle. So here's my central angle. Okay. Now I need the inscribed angle using those same two outside points on the circle. Let's label some points. This could be B, and this could be C, and the center of my circle is point D. Well, we also have right here point A. If we create an inscribed angle with these two chords, we have the enterprise communicator. So we can beam me up, because now you have the communicator. So that's an inscribed angle and a central angle. How are you?
Pretty good. Sounds good to me.
So let's mark the inscribed angle. We're going to mark it in orange. The inscribed angle is right here. It's not the central angle, because the central angle is the one that has the vertex at the center of the circle. So there's your center angle. This is just the inscribed angle. And this is the central angle. Okay? All right. Now, the theorem says this. The measure of the inscribed angle equals 1/2 the measure of the arc. So the measure of angle A equals 1/2 the measure of angle of the measure of arc BC. You see that arc that it makes right out here? The measure of that angle is 1/2 the measure of that arc. So let's put some numbers with that. Let's say that we're given angle D is 40 degrees. Right here, we're given 40 degrees. Well, do you remember in the definition of the central angle and the arc that it makes? Remember, the measure of the arc equals the measure of the angle. That was in our very first video. Therefore, we know arc BC from that is also 40. If we're trying to find angle A, if we're given the central angle, D equals 40, we're going to find angle A. Find the inscribed angle A. That's exactly how your problems are going to look. So you're going to let angle A equal X. Using the definition of a central angle, we know that arc BC equals 40. That's part of some steps and proofs. You're going to use that definition to make this deduction right here. They didn't give you that. They gave you something that lets you know that. So, the measure of the inscribed angle A is X equals 1/2 of 40. X equals 20. Angle A is 20 degrees. Okay? And if they had given you arc or central angle, if they had given you angle A instead, you would have just multiplied by 2. All right? And that concludes secants, tangents, arcs, chords, segments, sectors, all of that good stuff in 2 very long videos. And next what we're going to be doing is trying to find the length of these segments and chords from angle measures and things like that. Okay, but you are ready now to do your worksheet. I'm going to include it with the links to 2 videos. Remember, your attendance is going to be taken based on handwritten notes, which should be quite large in volume. You're going to email me multiple pages, I'm sure. I will miss you guys next week. Have a great one.